Hello, everybody. I'm Ken, and today I'll be speaking about functional programming in F#. We will be finding out, or I'll let you decide for yourself, whether functional programming is just a passing fad or whether it is absolutely fabulous. And for the viewers who are not familiar with these two, I recommend Googling absolutely fabulous BBC. Now, just to clear up any miscommunication, that's the British Broadcasting Company. I am Ken Bonny. I'm a freelance architect, team lead, coach, and developer with around 15 years of experience. And you can find links to my websites and my Blue Sky at this QR code. Don't worry if you don't have enough time to scan it right now. I'll repeat it at the end, and there is a link to it in the show notes. Also, you'll be able to find this presentation and all of the code that I'll be showing in a running application at this URL because it's just a GitHub repository that it links to. So what is the application and the things that I will be talking about? First of all, I'm going to highlight F# and I'm going to pair it with Wolverine. And for those of you who know Wolverine, will recognize this as a C# library. I'm doing this explicitly because I understand that most of you will not be able to go back home or go back to your day jobs and will not be able to stop all the presses to rewrite everything in F# and in a full F# stack. That's why I want to highlight how F# plays very nicely with C# libraries and with C# interaction. Next, we will move on to the basic building blocks of any functional language, and those are functions and the data types that they will be accessing. We will add computational expressions so that we have a lot of degrees of freedom, and we will dive deep into business modeling and special cases with discriminated unions and pattern matching so that we don't forget anything so that we don't forget to match on anything that we have described in the discriminated unions. Next, we will apply the piping mechanism to make complex functions out of very simple ones by combining those two, by combining smaller functions into larger and more complex functions. I will round off by giving some tips about message handling and how you can test your F# code. Now, when I first heard all of these difficult words, computational expressions, discriminated unions, I was kind of like my dog, and I was filled with despair. Like, these are such difficult words, they must be equally difficult concepts. And I can put your mind at ease. They're actually not that difficult and not that complex, but they are very powerful in how they transform your code to be more readable and a lot more concise. I will be applying all of these techniques in a demo application that will mimic a drone flight tracking app. So we will be creating and listing the drones under our command, and we will track flights that are happening. Now, this app will be overly simplistic and it will ignore a lot of real-world complexity. This is so that I can showcase what F# can do instead of getting bogged down into, well, we're comparing altitudes and all of those tricky things. So let's take a look at the technology. First of all, we've got F#, and that's why you're here. This is a functional first language with object-oriented principles baked into them and available to you. Just like C# is an object-oriented language first, but with functional components such as lambdas and generics added on later. I will show that F# requires a lot less boilerplate and is a lot more concise and readable. But that comes with a caveat. Just like when you over-apply object-oriented principles, you will get spaghetti code. You can over-apply the conciseness of F# and you will get something so small and so compact that does what you need it to do, but is not readable and will take you a week to unpack to find out what it does exactly. Another strength of F# is that it's part of the .NET ecosystem. So all of your favorite libraries that you are used to using, such as Fluent Validation, Newtonsoft.json, ASP.NET, they are still all available, and you can make use of all of them. As a bonus, F# has scripting built into it. So all of the things you see here, you can apply in scripts, and you might even get rid of those much harder to read PowerShell scripts. I will mention that order is very important right from the bat, because in F#, you don't just pay attention to the ordering of your parameters of a function or to the order of the functions within a file, because you can only call anything that has been declared on previous lines. If you look at the screenshots I have added, then you will notice that my files are not in alphabetical order. And that is because ordering is even important at the file level. You can only reference functions within files that have been created above the file you are using right now. So the top file will have no dependencies on any of your code. You can always open system libraries and NuGet packages, but you cannot reference any of your own code. So that will be your topmost, your basicmost, your innermost part of the system. While the last file is your program.fs file, which will know everything and will be used to wire everything together. I will be pairing F# with Wolverine, which is a messaging framework, and it can take messages from both buses as it can from, for example, the HTTP pipeline. It is very minimalistic, but it has so many configuration options and points to hook into that it becomes very extendable. I found it very reliable. It has retry mechanisms, error mechanisms. You can specify and configure this to your heart's desire. And I found this very easy to understand. But it uses convention over interfaces. And this gives it a nice tie-in with F# functions, because Wolverine allows us to not just specify the message that we're handling, but it can also do method injection. So the email service of this consume function will be injected through the dependency injection framework. And I will be using that in my C# code, my F# code quite a bit, because it is very convenient. So now that we know which technology we'll be using, let's dive into the setup of the API. And we'll go through this from top to bottom. And the first thing that we're noticing over here is that I'm defining an exit code. I'm using the let keyword to define both values as functions. And here we're defining not just any value, but we're defining a constant. And this is because we put the literal attribute on top of it. Attributes don't require just the straight brackets, but also the greater than and smaller than symbols, because when you use just the straight brackets, it will denote a list in F#. Not the C# list that you are used to, but an F# list, an immutable list. Because by design, F# values are immutable and cannot be changed after they are created, which in my opinion is a great way of ensuring that there is no accidental mutation or changing, so that once something is created, you will be certain of their values and what will happen throughout your code. Next, we will specify our first function, and we will also say that this is the entry point of our application. So we are going to create a main function and pass it some arguments. And the thing that you'll notice here is that I've never specified which type the arguments is, or what the return value of my function is. And that is because F# is so statically typed, so strictly typed, that it can infer a lot of types from usage. For example, the args are used on the next line in the create builder, And the create builder function takes an string array as input, so my args must be of type string array. And every function in F# will return what is on the last line of the function. And in this case, it is the exit code. And because the exit code is an integer, this function will return an integer. The rest of this function will look very, very familiar to you, and it will almost look like C# code. And that's because it is. This is just an ASP.NET setup of a web server. We will register services, we will build our app, we will use HTTPS redirection, and we'll use Swagger, and we'll use Wolverine endpoints. All of the things that you are used to in C# will work just the same way in F#. But there is one line in particular that is a little special and that requires some additional explanation, and that is the line in the very middle, the use Wolverine function. So why don't we zoom in a little bit on that one? Here, I've shown you the use Wolverine method signature, and it will take an action that expects Wolverine options. But I've called this setup with a function called configure Wolverine, and I'm passing it a configuration, the configuration from our app settings. That is, this is the function, and it doesn't just take a configuration, it also takes the Wolverine options and returns unit. And unit is the same as void in C#. And what this is partial application. When I specify not all of the arguments of a function, the function will return a new function with the remaining arguments as their parameters. So the action, which is a function that that expects Wolverine options and returns nothing, will be the rest of our function. And then it can be used as a function. It can be passed to the use Wolverine setup method, and it will run the code as is. And notice this last line. As I said, every function returns what is on the last line, and this is the type for unit. So it's two rounded brackets that specify nothing. If you want to create a function with no inputs, you also specify that it has unit as input, and you specify the two rounded brackets. This is funny because all of the functions in C# that take no arguments take two rounded brackets. They take nothing as input. So with our API setup out of the way, let's take a look at the first endpoint that we shall be creating. And when we are creating a get endpoint, we are also specifying something that we will be returning to our client. In this case, we will be retrieving a list of drones in our system. To model this system, we can create a type like a drone DTO that we will be returning to our clients, and we will specify a make and a model. And a make is a string, and a model is a model, so that we can easily talk about it and argue about it, because behind the scenes, this is an alias for the type of string that is defined one line above. So type model equals string makes it an alias. So model can be used as a string. C# code will not differentiate with it. It will serialize it or deserialize it when it's an HTTP request body that needs to be retrieved. But we can make our model much more aligned with our business. We are not making everything a string. We're like an email is a string and a model is a string, but those two types are not interchangeable. So this is a way of making it more explicit that these are different types that we are talking about. And you can take this a lot further and make it very strict that you cannot assign an email to a model, which you can with type aliasing, but that would take us too far for a first example. Next, in our code, we have tags and a get endpoint, or the definition of a get endpoint through the attributes. And then we have a function that takes a page size, and a drone context. And Wolverine is smart enough to figure out that the page and the page size are parameters of our HTTP request, and that the drone context will come from our dependency injection framework, which is really nice. But I want to use the page and page size not as nullable, because if I try to access a nullable, I could have a runtime exception. I want to get either the value inside of it or create a default value. And that is what the retrieve page function on the next line does. It takes the nullable page and page size, gets either their values, and calculates the correct page to load, and then returns them. And I assign them to the exact same named symbol. Well, it's not the exact same name. It creates a new symbol with the same name. And thus, you lose access to the nullable int, but you gain access to a page that is an actual value so that you can never be mistaken. Be careful, this is not mutation of the nullable int. This is the creation of a new value. So you don't lose access. In this function, I would lose access to the nullable int, but calling code will still have the exact same nullable int with its value without that it has changed. This is very nice, as when you pass in a list and you change it or you give it a new name, you will not be changing the original list. Your calling code will still be working with the same values as before. So you're not using mutation. You're just reassigning the symbol. The rest of the function is a entity framework call, as we are all familiar with. You have your context. It goes to the drones table. It orders by make and model, and the order by uses the full syntax of an anonymous function, while the then by uses the F# shorthand, because the underscore can be used to access a single property or a single function on the object that is passed into the anonymous function. So if you want to use where on a simple object, you could say where model is this value, but you cannot use multiple properties. Then you will have to go back to a full anonymous function. Next, we're going to skip and take the page and the page size. So we're going to apply pagination, and then we are going to select our drone entity into our DTO, again, without specifying the type, because it is defined above this line, so very close by. F# can easily figure out that that this type is of type drone DTO. There is one little downside to this type inference. You won't get autocomplete until it figures out the right type. So sometimes, in the case of this drone context, I might want to specify the type, as I don't want the compiler to keep guessing which type I really want to use. And sometimes when it can't define between the drone DTO or the drone entity type, it will come and ask us to help it out. But in a lot of the cases, it will just figure it out correctly, and you can use it without any problems. I've used Entity Framework, and I've used F# to set it up. So how does that look like? Well, it kind of looks like your normal C# setup. We inherit from the database context. We create two constructors, one empty and one that takes DB context options. And then we specify a member that is the drones, and we retrieve a set of drones. This set is a built-in function from the DB context, because in C# we have auto properties, but in F# we do not. So you can specify a full property, but you will have to do this with a backing field, just like the C# from a while ago. But with new DB context, with new entity framework changes, this is even easier. So we don't have to make a full property. We can just have this member on our type. There is one thing to take into account, and that is the type, the entity type that we are creating, in this case, the drone type on the right. F# is always immutable. So when we pass this type to entity framework and it saves it to the database, it cannot make updates to it. It cannot replace the actual database ID. It cannot place the actual database ID in the ID field. So to get around that, we could either make it mutable, so it can change it, but then all of our code could change the ID, or we could apply the CLI mutable attribute, and this allows entity framework to make the changes to the ID, but the drone entity itself in our code will be treated as immutable, and we will have to use the with syntax to make changes to any object that is of this type. So we get the best of both worlds. Entity framework can do its thing, and we still remain and we still maintain our immutability throughout our own code. So now that you have a good idea of the setup of our entity framework, let's take this a step further and let's create a drone. And in the top right corner, I have specified the setup of our command, the create drone command, which we will be getting from the HTTP body. And we have specified a message that we will place on the bus. We will create a tags attribute and specify that this is a post endpoint. And we'll create our function. And then there's a little special little thing here. We have this task keyword, yet there is no task keyword in the entire F# language. So let's investigate a little further, because we're placing this between curly braces and then we're just using code. So this is something special. In the code, we are mapping our command, our create drone command, to an entity, to a drone entity. We're adding this to the database context, and then we have this strange let declaration. It's with an exclamation mark, and you pronounce this as let bang. And this will, in this context, allow you to use asynchronous code. I will go deeper into this in a moment. When the save changes is done, we will create the message to be placed on the bus, and we will return a tuple back to Wolverine. And Wolverine is smart enough to see that we are in a endpoint. So the first value of the tuple, it will use as the return value back to our clients, and the other objects will be placed on the bus. It will publish it to the bus that is known, that we have configured. But let's take a deeper look at what this task and this let bang actually is. And this is a computational expression. And a computational expression is a convenient syntax for writing computations that can be sequenced and combined using control flow constructs and bindings. This is what the official documentation on the Microsoft website says. What it actually means is that computational expressions allow us to add language features or domain-specific language components to the language. It means we can extend the F# language in any way that we need it. For example, in the task context, let bang or do bang is equivalent to an await in C#. But that's not the only thing we can do. For example, we have the seek functionality, which is equivalent to an IEnumerable in C#. And you can use this as in the topmost example, as in you'll loop over the numbers of 1 to 10, and you will return one by one the square of the number. But you can always also use this to list all the days of the week or a number of specific values, including optional weekends. And we can add this with a Boolean that specifies whether we want the weekends or not. Because in the seek computational expression, the yield keyword is implied. Every line that is a value will be returned as one of the values in your sequence. We can take this even further, for example, with the FSHTTP NuGet package, and this allows us to create HTTP requests with specialized syntax. For example, there is no post keyword in the F# language, yet here we can use it to describe what kind of request we want to build and to what endpoint we want to use it. We can very easily add headers and tell it to add a body, which uses JSON as serialization, and we can use it and we can pass it on an object. Lastly, we'll pipe it on to the request.send functionality and we'll send it out over the network. It reads very fluently, it reads very nicely, and I will be returning and I will be going deeper on the pipe a little later. Because right now we're about halfway through the presentation and a lot of you have probably a skeptical look on their face, just like my dog here has. Because all of these features are quite nice. It makes it a lot more concise to write your code. But C# is a well-rounded language, so we don't really need to extend it anymore. Why is F# a better choice, in my opinion? Well, for that, we need to dive into the two most powerful features in the language, at least according to me. But before we can do that, we need to talk about what a flight is. And a flight is a path that a drone will take. So we will have to specify a drone and the route that it will follow. For the sake of complexity, I will ignore dates, I will ignore flight speed, I will ignore altitude, I will ignore quite a bit of things so that I can focus on data processing and business modeling instead of real-world complexity. So when I'm talking about a flight, the first thing I need is a coordinate, which is just a latitude and a longitude. And then we are going to take about a flight path. And a flight path consists of several nodes, of which we have takeoffs, we have waypoints in the air, and we have landings. But we can combine these in any order we want. Well, preferably we start with a takeoff, and then we will fly a path, we'll land, we'll take off again, we'll fly further, we'll land again. And we will describe this in the flight entity with the CLI mutable to make it accessible to Entity Framework. Next, we will determine whether a flight is a valid one. So we want to have a flight registration with either a rejection, which can have a reason, or we can have a registered flight, and then we'll get a flight back. And the flight node and the flight registration are what are called discriminated unions. And this is how you write them. And what are their benefits? Well, they can be they can have a set of values over a set of choices which allow you to limit what you accept or what you return. And every case can have their very own data type. For example, the flight rejection will have a reason, which is just a string, or the flight acceptance will have the flight type as backing type. This is very good for commands, for domain concepts. You can model special cases or errors with them. And to get to the actual value, to the rejection or to the registration, we have to use pattern matching to handle every case. Just like in C#, you can use a catch-all pattern, but I avoid against that. Why? Let's take a look at pattern matching. And this is how you pattern match on the flight registered or the flight registration type. You either have the rejected with a reason, And then we will return from our endpoint that there was a problem. We will specify the reason. We'll put a message on the bus with the flight registration inside of it, and we will not be saving a flight to the database. But when we have a valid flight registration, we will give it back the ID of the flight. We will post the same message on the bus, which we can later on again pattern match on, and we will save our flight to our database. But what happens when I add a new case to my flight registration? In that case, my compiler will say that my pattern match is incomplete, and it will start yelling at me that I've probably created a bug or that this will crash during runtime. And this is very convenient, as the compiler will tell me where I have forgotten to implement this new case. There are a few famous examples within the F# language. And the first one is the option discriminated union. This is basically the equivalent of nullable, but it is much more safer, because with a nullable, you could try to access the value inside of it. But with an option, you have to pattern match. You have to explicitly say, when I have a value, this is what I want to do. And when I don't have a value, this is the other thing I want to do. Next to option, we also have the result type. And result also consists of two options. You have either an OK, which has one type of value, or we have an error, which can contain the error type. This is seen a lot in algorithms and in business code, and for example, validation, because it's very powerful. Now that we have discriminated unions and we have computational expressions, can we combine them somehow and make something really great? Well, yes, we can. And this really great thing is called railway-oriented programming, because we are going either to go along our happy path, or we are going to exit early and bypass all of the rest and return the error straight away. Now, how does this look? Let's take a little detour from our flights and say that I want to register a user in our system. A user has an email and an age, but it can also fail because we didn't specify a correct email, the user is too young, or the age couldn't be parsed. And when we look at the parsing functions, we'll get an email as a string. We'll check if it contains an @ which is a great way to make sure that this really is an email. When it contains an @ we're saying this is a fine email, else we're saying there is an error of the type not an email. And we can do the same thing with the validation of the age. We'll get the age as a string. We're going to try and parse that into an integer. And when the parsing works and the age is over 18, we have an OK user. When the age is below 18, our user is too young. So we'll return that as an error. And in case we can't even parse it, we'll return an error saying that it's not a valid age. Notice here that the pattern matching works just like a switch case, where you fall on true to the next case when the first one doesn't work. So when we have valid parsing and our age is over 18, we're in this case. Otherwise, we will continue down the list until we find one that works. Also, I have used the catch all pattern here because I am fairly certain that I cannot change the try parse function, and thus I cannot add any more combinations to the result of this function. So in this case, it was, for me, a good usage of the catch all pattern. So now let's combine these try parse functions into an actual function that does something. And for that, I will use the FS Toolkit NuGet package, which is the Swiss Army knife for functional programmers. And this contains a result computational expression, which will say that we're going to parse the email address, we're going to parse the age, and it will assume that we got correct values out of it. And we can combine these values and return this as a valid user object. What happens when we get invalid users? When we get an error back, we don't have to write repetitive if statements or pattern matching and try and see if we have an okay value or not. That's what the binding does for us. That's what the let bang is here to do. So if the try parse email returns an error with an invalid email address, we won't go to the parsing of the age, or we won't, and we will not try to create a user. We will just exit early. This can be used in a lot of different ways, and we can even combine these parsings. But as a basic example, this shows very nicely how this simplifies our code and requires us to write a lot less boilerplate. It's hopefully a theme that you've noticed throughout the presentation. But let's get back to the registration of our flight. And this code here will look now very familiar. We're creating a post endpoint where we will register our flight. We will pass it the ID of the drone, and the flight path list will come from my apologies. The flight path list will come from the body of our request, and we will get a drone context from the dependency injection framework. The task computational expression lets us work with asynchronous code, so we can call the database to find the correct drone and to load all of the lists in our database. We will pipe the list into a sequence because that works a lot more smoothly within F#, and we will try to validate our flight against all of the existing flights in our system. Like I said, this might need some tweaking if we want to use it in a real system, but it shows you nicely that this is a very concise syntax. Lastly, we will put the flight registered discriminated union inside of a message, and that's the message that we will be publishing to our bus. And why I do this, I will describe a little later. But first of all, I want to take a look at the validation of the flight. Because our drone entity is coming from entity framework, this can be a nullable. And the first two lines is how you define, how you check for nullability in F#. This is a little bit more work because F# starts from the idea that we will not be using nullable, that we will be using the option pattern, and that we will use the option discriminated union, and that we will pattern match on that. But the more important thing happens in the else branch, because here we are defining a function that will check if there are any collisions along our new flight path, and it will compare this with the flight path of an earlier registered flight. This will give us a list of nodes, a list of coordinates where collisions happen. So if I have a new flight path and I have an existing flight path, it will give us the 2 points or all of the points along which collisions occur. So let's take all of our existing flights. We will loop over them and we will collect all of the collisions. And the collect function here is basically a select many, so that we get all of the lists that contain collisions, all of the coordinates that are collisions, and we are putting them in one big list. Next, we will be sorting that list so that the earliest collision appears at the top, and we will try and get the first one. We will try and get the head of the list. And the try head will return us an option of coordinates. Why? Because if there are no collisions, then we are going to have an empty list and we are not going to have a first element. And that's what this function does. It's going to pattern match on either a coordinate that we found, and then we're going to reject the flight because there is a collision, or we don't have collisions and we have a valid flight. Now, this function keyword is the exact same thing as the 2 lines that I just showed below. And because pattern matching is such an important part of F#, there is a shorthand to writing an anonymous function that will just pipe its input through to the pattern matching that you see. So this is a very used function. So this is a very used pattern amongst F# programmers that it has made its way into the language. But even more important are the straight line and the greater than symbol, because this is the piping symbol. And unwittingly, you've probably read this correctly. It takes the output of the left-hand side and passes it on as the last parameter of the function on the right-hand side. This allows us to compose different smaller functions into a larger pipeline and into much more complex functionality. I have written the previous lines in which I've used piping as statements that you would probably use in, for example, C#. So you would define your detect collisions function. You would pass in the existing flights into the select many function. This will give you all of the collisions. Then you will sort these collisions so you get a sorted list, and then you will try and get the first one from this sorted list. Or when you write it with piping, it becomes this short little stack, which is a lot more easier to read, at least in my opinion. And my dog agrees, because she can stretch herself on the couch that she takes up half of it, or when she wants to, she can compact herself in between me and my wife. And this is exactly what piping does. You can still write it the long way if you like, but if you use piping, you can save yourself a lot of typing work and make it more readable at the same time. Let's get back to pattern matching a last time, because I want to show you how powerful it can be. When we want to detect a collision between two flight nodes, pattern matching can help us, because we can do pattern matching on one item, on two items, and on a lot more if we'd like to. With more discriminated unions that we pattern match on, or anything else, because you can pattern match on strings and on booleans and on anything else. So the more items we add, the more complex it will be, but our compiler will also help spot mistakes, because if I fail to specify a specific combination, our compiler will yell at us. It will go, hey, you forgot the combination of takeoff and landing, for example. So it helps us avoid mistakes. At the same time, even though this is a little bit more verbose, it also specifies all of the options so that you can never forget to think about a combination, because you've hopefully gone over all of your options through in your discriminated union. And if you have forgotten them, you can add them. And the language itself will help you avoid bugs. And lastly, in the collision function at the top, we are just comparing the first and the second item, in this case, both coordinates, and F# uses value comparison instead of referential comparison to match on objects. And in this case, it's a quite simple object with two properties. But if you have complex objects, it will go throughout the whole tree and compare all of the existing values with one another. This would have saved me a lot of comparison and equality checks in the past in C#. Because in a lot of cases, when we are comparing two objects that are the same type, you kind of just want to compare all the values. Now, with discriminated unions and pattern matching, with great power, there are some disadvantages. For example, there is um, a lack of serialization in the .NET ecosystem. The only library that I know of that has good serialization support for discriminated unions is newtonsoft.json. At this point, system.text.json does not have support for discriminated unions. Now, there is confirmed that there are going to be unions in the next version of C#. So hopefully this point and the next point will be solved by this time next year. Here's the hoping, because there is also very limited, well, actually there is no entity framework support. For every discriminated union, you will have to write a value conversion. What I usually do is I serialize my discriminated union to a text, to JSON, and I save that to the database in a column of my choosing. And then when I load it, I deserialize it again and assign it to the actual discriminated union type. When you're interacting with C# code, you will also need to map your discriminated union to an inheritance hierarchy, because, like I said, C# right now has no equivalent of a discriminated union, so you'll have to map that to an inheritance structure. When you are using messaging libraries and you're using in-memory transports, I'm thinking Mediator and I'm thinking Wolverine there in-memory transport, that works fine because you're just sending it throughout code. But when you are sending it throughout an actual bus, such as RabbitMQ, Azure Service Bus, or Amazon SQS, you will need to use a serializer that supports discriminated unions, and you will have to wrap it in a generic envelope. And why is that last part? Because you will register a handler that says, I have a flight registration. I have a handler that expects a flight registration object. And on the other hand, I have the actual type inside of it, for example, flight rejected. And it can't match those two up. But when you put it in an envelope, it magically works. How does this work? Well, at the top, you will see the envelope that I created. I called it a discriminated union message. I gave it a generic parameter, which starts with an apostrophe in F#, and I've assigned it to a property called payload. And then I've created a special message, a special function called toMessage, which takes the discriminated union and just places it inside of the envelope. This is to make this kind of code very easy to read, because we're taking our discriminated union, putting it in the envelope, and then passing it on to our message bus. And I have seen this work with Wolverine and with Service Bus. So it is my opinion that the other kits, the other messaging frameworks will also perfectly support this kind of communication. Lastly, we're going to need a handler that receives the discriminated union and does something with it. And like I show here, you can just pattern match on the payload and it will work nicely. You can try this out in the code that I have provided. So when we have all our functionality, we also want to test it all. And testing is very simple because you can just use the current frameworks. Like I did here, I've used XUnit. You can also easily use NUnit or even the new kit on the block, TUnit. And your tests will follow the same pattern they always do. First, you're going to create your test data, in this case, a drone, some existing flights, and a new flight path. Then you are going to call the system you want to test, in this case, the validation of the flight. And as a last step, you're going to assert that you have the correct values. And pattern matching can even help you, because now you can already see that because you can already see that there is the expectation that we are getting a flight registered. F sharp has a last feature that I want to demonstrate that is very nice for automated testing, and that is you can put any text in between back quotes, and it will be a valid identifier for an object or a function or anything. And you can put all you want in between those in between those backticks. So you can use keywords of the language, but you can also use emojis, as you can see here in the name of my test. And when you run those tests, instead of just camel cased or underscored names, you get nice sentences with, everything that you would like. So this renders very nicely in test runners. This brings us to the summary, to the ending of this talk. And we've talked about functions and types and how you can define them, and that they're the basic building blocks of F# and of functional programming. We've seen how discriminated unions can help us dig in, can help us specify our cases and our business model in a very high degree of detail. And pattern matching helps us to never miss a case that we have described in our discriminated unions. We have also seen how piping can help us create complex functions out of smaller ones, and we are combining them through I forgot my words. We can take smaller functions and compose them into larger and more complex functionality using the piping syntax. Lastly, I've shown how computational expressions cannot just create domain-specific languages inside of F#, but how they can be used to extend the language to do new things that are not yet inside of the language itself. So you can extend the language to your heart's content. Writing them is not always easy, and I've steered away from that, but using them is very intuitive and very easy, but you kind of need to know what the let bang syntax stands for. I have found that this comes quite intuitively once you know how this works. When you want to start writing your own F# code, I suggest you start with scripts and automate some things on your own machine and try to replace some PowerShell scripts or Bash scripts with some F# scripts, because all it takes is a .NET FSI for F# interactive, and then you give it a file with the extension FSX. And then you are off to the races and you can start your scripts. And with that, I want to invite you to ask any questions. And at the same time, you can scan the QR code here and go to the GitHub repository where you can get all of the code and all of the slides, even my contact details.
Hi, Ken. That was a fantastic session. Thank you very much. There was covered a huge amount of ground there, but really cleanly and clearly. And I loved using a real-world usage for that too. It was really cool. Thank you.
It was fun incorporating both one of my hobbies and my dog into the talk.
Yeah, we've all decided in the chat that including your dog is cheating. It's it's too emotional. We're all like, yeah, okay, the dog's in, we're in. That's how it goes.
Good. It's my plan is working nicely.
Fantastic. Where are we? We did have a couple of comments on the chat there. You're talking about the serializing F# unions, for example. Somebody's commented that you can use what is it, F# system text JSON? I don't know if you've come across this one.
Yes. I have not used the F# specific ones. So there are probably some F# initiatives to enable serialization efforts. But from the official Microsoft packages, there is a lack at this point. And I have used Newtonsoft.json for my serialization needs because it nicely ties in with C# libraries, and they have nice support for C# if you want to interact with C# and F# code together. Like I said, I did not want to make it an F# talk alone because then you go like, oh, that's a nice full F# stack, but how do I apply it? When you are working with C#, Newtonsoft.json is your friend because you can, because it can come from dependency injection framework. It works nicely with ASP.NET and C# frameworks such as Wolverine, such as ASP.NET, and so on. So if you are remaining in the F# world, great, you do have some options. But when you're combining it with C#, Newtonsoft.json is your friend.
Awesome. Yeah, I was wondering as well, we've got the chat going on there. I'd actually like to ask the chat if anybody's using F#. Obviously, we've got a couple of people who are definitely using F# in the chat,
Yeah.
but I wonder if anyone's using it for hobby projects, for example. You mentioned that a good way to start is with your scripts. I guess a hobby project would also be a good thing too.
Yeah, I've used it myself for I'm a freelancer, like I said, and I need to make invoices. I've used it to automate the creation of my invoice. So I log all of my time in Clockify, and then F# reads the output and generates a nice PDF invoice for me. So that's how I automate my the last workday and skip right to the fun part of getting an invoice to send to my customers. Sorry, customers.
The payment is the best part. It's got to be said.
Yeah.
It's good. So it's interesting as well. Sort of moving to use F# from C#, for example. How hard do you think it is to actually sort of migrate? Because there's a bit of a change of mindset there as well, I think.
Yes. There are a couple of new concepts to wrap your head around, and I have found that if you give C# code to ChatGPT or to Claude or to a lot of the AIs, it will give you back an example F# function. But I would suggest you try to do it yourself first so that you can get a feel of these concepts and play around with them. And then you can compare it to what the AI did, or you can, challenge your friends to come up with the most creative way to convert the C# code. And then compare notes either with an AI with your friends. But that's the way I've been experimenting with it. And I'm not saying I'm the greatest or the best F# developer, but I have seen a noticeable difference when I've learned these concepts. I've been applying them gradually to my C# code as well, and that's resulted in for me more robust and more fluent code, and sometimes more easy to read code. Even though there are not always the concepts that I like, such as discriminated unions or the piping syntax, but focusing on functions first and functions that always return a value and never mutate state has been a great way to improve my C# code and to have less bugs and less side effects.
Yeah, those are some important concepts that, especially, coming from that F# world, if you can adopt it in C#, that's a great way. If a C# developer doesn't get those concepts, like, is there, something else you would recommend, a library, or just, use, refactoring or something like that? What would you say?
When you're not familiar and you want to try F#, write it first in the way you are used to, because F# supports all of the known C# and object-oriented principles like while loops and for loops and ifs, and then try to work them out one at a time. Oh, I have a value that I mutate. can I get that out? And can I create a function that returns the new value every time? Can I convert a loop into a recursive function? Because I didn't talk about recursive functions because they're a whole thing on their self. But can you convert your loop into a recursive function and learn something from that? So work step by step and apply the same principles that you do in your everyday job. Work in small steps, commit often and early, do experiments, and see what the effect on your code is.
Yeah, nice.
Lots of tests as well, I think, is a good one. I like that you showed that you can do testing in F# as well.
Yeah. And F#, because of the shorter syntax and you don't need to use all of the things, it can help you write your tests in a very simple way. And so you can omit a lot of the types because F#, the strict typing system recognizes C# types. So if you want to start with your if you want to start with replacing your tests by F# code, that's also a nice place to start because then you can also experiment how the inferred typing can help you or sometimes get in your way. Like I've found it very convenient that it just says, oh, I know that this is a string or that this is a drone object, and sometimes it goes like, oh, you want a context? I don't know what you mean. I'll let you type random things until I figure it out, and then I'm going like, okay, this is where I might want to, add a type hint to help the compiler find the right thing. And those things you can only learn by experimenting, by, sometimes getting a little bit annoyed with it, and but continue your experiment because you see that the annoyances are very few and very far in between, and that the resulting code is really nice to read. I have to say, the F# community in general is one of the nicest I have ever encountered, and there are some great resources out there. For example, F# for Fun and Profit. I've learned a lot there. And there is a Discord, and they are very friendly and very welcoming. And they always like new people and helping out where they can.
Awesome. That's fantastic to hear. It's always nice to hear of good community going on there as well. Although I do have to say, I think you might have upset somebody with PowerShell there because when you mentioned it's all nice to read, somebody has replied back and said, how is this? One of your slides has said, how is that more readable than PowerShell? So I hope you're not trying to set up beef between the F# and PowerShell communities.
No. But I'll reword it. The PowerShell that I've been writing is a lot less readable than the F# that I've been writing, which may say more about my PowerShell skills than my F# skills. And maybe, like I said, I've been over-applying the shorthand syntax a little bit too much by making it too concise, which then circles back to the other way and makes the code a little less readable. So there is a balance to find there. And some of it is how familiar are you with F#? Because I've seen some F# code that I think, wow, I'll never think of that on my own. And then I've seen other F# code and I'm going like, hey, I can improve on that. So
sorry.
I was just going to ask then, what about performance, right? If is there, do you get performance or is there a hit? And is there anything particular for, let's say, CPU heavy workloads?
F# performs just as well in most cases when doing a lot of computations. Where you can have an impact is when you use a lot of discriminated unions and you do a lot of pattern matching. That can be slower. We're talking about milliseconds here. So we're talking about very small differences, but they can compound if you do millions and millions of calculations. So there are scenarios to take that into account. But if you're writing everyday line of business applications, there is very little difference between C# and F# at the moment. But there can be certain cases, especially around discriminated unions, because they do add a little bit of overhead because they offer options and not just the direct access to an object that can slow things down.
Is there any particular .NET workload where you would say, hey, if you're building WinForms or, mobile apps or something, where you say like features of F# would benefit those devs?
That's a good one. Places with complex business logic, with a lot of edge cases that you want to keep track of, and where you can say, oh, either have in nine out of 10 cases, I have one case, but the other 10% are one of these 5 cases. That's a very good example for F# because the language helps you write good code and helps you not to forget those cases. And even when business later comes with, oh, we forgot a case, you can add it to your discriminated union. And F# will help you point out like, hey, you forgot to handle that here and here and here. So you can immediately see the impact of those changes. So complex business that that can, I don't want to say that can be slower, but that can be less performance critical, is a very good target for F#. And even if it is performance critical, there are a lot of steps you can take to minimize the impact and to keep discriminated unions out of the most critical parts of your system when it comes to performance.
Mhm.
That's
Yeah,
something that I've learned.
Discriminated unions are a thing which I really like about F#. It's got to be said, and I'm looking forward to seeing if we ever get them in C#. I know there's a proposal right now. Have you seen the proposal actually?
Yes, I've seen Nick Chapsas talk about it,
Right.
and I've heard about it through him.
Yeah, I don't know, because it always seems a little bit disappointing that a lot of F# concepts, which are really popular, great concepts, make their way into C#, but in a way which is slightly different and don't quite fit so cleanly, or at least, sorry, the interop between the two languages is not so clean. I hope that we can get something with like discriminated unions where it's a bit nicer in that respect.
Yeah, I like to look at it that F# is a good influence on his bigger brother, and that C# is learning a lot from the smaller language, because I believe that, for example, the link syntax is a direct consequence of the piping in F#, because those two have a lot in common in my eyes. So when it comes to adding discriminated unions to C#, yes, it is not native because the foundation of each language is different. But I like that the functionality is moving into a more functional approach, so that we have a lot of the power that comes from F# is carried over. And it might not be 100% the same, but there is a lot of benefit in adopting all of these practices. And I think it's nice to see C# evolving in that way. I still prefer F# in a lot of cases because a lot of the concepts that C# is adopting, they are adopting, and they are not baked into the foundation of the language. So, for example, I think it will be very hard to get something like partial function application into C# because of the way they have functions, and they're not the same as in F#, and that will inhibit certain things from being, ported over. So I think we will get a number of good ideas that come from F#, such as generics, lambdas, the piping syntax, and now discriminated unions. But I don't think they'll get there the whole way, because how partial function application is built up is in the core of the language. And that is not something you can easily adapt into C#. Now, I wouldn't put it past the C# team to find a very interesting approach to get it in there. I just don't see it happening very soon. But then again, we've had the request for unions for years, for almost a decade, I believe. And finally, we're getting them because they've moved in very gradual steps. They've added pattern matching. They've added all of the things that are necessary to be at this point to include unions. So maybe in another decade, I will be talking about how C# has partial function application.
It's something to look forward to, isn't it? But I think you're right. I think something like partial functions is something that's very. It's really it's a much better fit for a functional language. And C#, although it's got a lot of functional things in there, it's not a functional language. It's more of an imperative language, and it works better for that, I think. So each language has their strengths, and so I don't think we'll see the same things in each. Not all of them, but just some of the nicer things would be good.
Yeah.
I think we'll just finish on one last question, which is a nice one here. Is if you're wanting to move from C# to F#, what is the one habit that what is the one C# habit that F# kind of forces you to drop?
C# has a lot of combinations between an object with data and functionality on top of it. Splitting those two will help you get into a more F# and functional paradigm. You're going to think a lot more about, I have a function that does something, and it will take data, instead of I have a function together with my data. And that's been a really big help. And when we're winding down, could I have my slides for one last remark, please? Because when I learned F#, there was something that when I learned it, it blew my mind. And that is the piping symbol a keyword in the F# language, like let or matches? And I kind of put this in for a live audience because I find it very hard to see hands going up. So I will give you the answer, and the answer is no. The piping symbol is an operator, just like a plus or a minus is. And this is the entire declaration of it. So one of the most powerful features of the language is not just a one-line function, it's not part of the language. It's a consequence of good language design. And when I learned that, it was game over for C#, actually.
That's a great slide to end on. That is a brilliant example of the power of some of this stuff. Thank you very much for a brilliant session. We've learned a lot, and you've delivered it in a really lovely, clear manner. So thank you.
All right.
Yep.
Happy to be here. And like I said, if anybody wants to meet me in person, I'll be over at Build Stuff in December, giving this exact same talk. So, say hi on Blue Sky or in real life. Bye-bye.